Okay, so this time our topic is about metadata online analytical processing or yung OLAP, no? So data warehousing OLAP, no, or the online analytical processing server, no, is based on the multidimensional data model, no? So it allows managers, no, and analysts to get an insight of the information through fast, consistent, and interactive access to information. And this OLAP, no, operations on OLAP, difference between OLAP and the statistical database and OLTP is very important, no? So there are certain types of OLAP servers, no? So we have 4 types of OLAP servers. We have relational OLAP, we have multi-dimensional OLAP, we have hybrid OLAP, and specialized SQL servers, no? So the relational OLAP or the ROLAP servers are placed between relational back-end server and client front-end tools to store and manage warehouse data. So ROLAP use relational or extended relational DBMS. No, ROLAP includes implementation and aggregation navigation logic, optimization for each DBMS backend, and additional tools and servers or services. Now, the multidimensional OLAP or MOLAP, no, uses array-based multidimensional storage engines for multidimensional views of data. So with multidimensional data stores, the storage utilization may be low if the data set is sparse. No? Therefore, many MOLAP or multidimensional OLAP, no, is server use 2 levels of data storage representation to handle dense and sparse data sets. Hybrid OLAP is a combination of both ROLAP and MOLAP. No, when we say ROLAP, relational. When we say MOLAP, that is multidimensional. No? So it offers higher scalability of ROLAP and faster computation of MOLAP. So OLAP or hybrid OLAP servers now allows to store the large data volumes of or detailed information, and the aggregations are stored separately in MOLAP store or MOLAP store. No. The last one is the specialized SQL server. So a specialized SQL server provide advanced query language and query processing support for SQL servers, no, or queries over star and snowflake schemas in a read only environment. So when we say OLAP operations, now we have based on multidimensional view of data, and the operations list of OLAP is roll up, drill down, slice and dice, and the 5-boot or rotate. No, so I just want to share again a video presentations about this discussion. No.
Welcome back to my channel. This is for ASM 654 on the digital warehouse. So we are on the topic number 7, chapter number 7, on the online analytical processing, or based known as OLAP. Okay, ready your pen and pencil? Prepare a note for this one. This is important chapter. The most critical part in the data warehouse is about OLAP. Okay, OLAP. Okay, there are 3 topics that we will cover on this chapter. Number 1 is on demand for online analytical processing on this OLAP. And of course, we look on the second one on the major features and function of OLAP. And the last one will be the models of OLAP. Okay, if you use my Google Classroom note, you will be noticed that some of the slide is empty, actually it's blank, so you can just refer this video for the explanation. Okay, so we may start now. All right, the first one. Okay, this is just like what I can say, this life is like a canvas, it begins blank and every day is like another brush stroke. So yes, okay, it's up to you actually how you want to make your days. Okay, upgrade yourself, upgrade your skills, so it's up to you. So you have to need just something to bother, something to mind lah. Okay, teacher poses a question, scan the audience. Yes, you don't make eye contact, mostly in the actual classroom. Luckily we don't have this physical class, so I hope to see you maybe next semester. All right, for this introduction of OLAP, the source is on the YouTube. So actually you can just Google OLAP here, search OLAP here on this YouTube. You can see what is OLAP, okay, what is OLTP versus OLAP, beginner guides to OLAP. You can watch anything, because actually I think the first one on this one 9 years ago. It's actually a bit old on this video, but yes, actually this one sebenarnya lebih kurang 5 years ago. But you can look on this one most recently, 1 year ago. Maybe you can filter something somewhere by this year ke? Ada tak? Keluar OLAF ni. Maybe you can watch this one. What is ETL, what is data house, or LTP versus or OLAP. Okay. Even this I think from CSE concept with Pranita ni is another drill down, more explanation on this data mining and data warehouse. You can look on. Okay, on OLAP this actually some model actually. Rollup, MOLAP, HOLAP is another things. Okay. All right, back to our slide, because what we will learn today is more on basics, more to introductions. All right, next slide is the topic outline. Okay, you will know on the OLAP definition, key features and benefits, how OLAP differs from OATP or OLTP, multidimensional data, why, what, how to use, and what is OLAP server query, features and application, of course the category of OLAP tool. Okay, this one still on the topic 1, data warehouse and end user access tool. Because the accompanying growth in the data warehouse is increasing demands for more powerful access tool providing advanced analytical capabilities. So key development include the online processing, analytical processing, of course with the SQL extension for complex data analysis. SQL is search query language, how they want to find the data lah, how to jump to the data, okay, get the informations, and of course the data mining tools. All right, so we're gonna look on this demand for online analytical processing, because need for multi-dimensional analysis, because it's not just straight away analysis. We want to have a multi-dimensional, okay, something that can produce much bigger sites or talks to our data that we can use for decision making, for the future plan analysis, and so on. Of course, another one is fast access and powerful calculation. We can predict, or we can assume how much the profits, how is gonna be on the next quarter of the year of business growth, business profits, and so on. Okay, limitation of analysis methods. Okay, this is the beginning. report writers. Two features: the ability of to point and click for generating and issuing SQL call, and the capability to format the output reports. However, report writers do not support multi-dimensionality. It's just a basic report. Okay, you cannot drill down to lower level in the dimension. You cannot rotate the result by switching rows and columns, and the report writer do not provide aggregation navigation. Once the report is formatted and run, you cannot alter the presentation of the result dataset, and the spreadsheets are still cumbersome for showing all the aggregate levels and multidimensional view, let alone doing calculation for roll up and drill down. Meaning that here on the basic report that we produce, maybe from Excel, maybe from basics, word processing, we didn't get enough multi-dimensional data. We cannot drill down the data. We cannot olah lah, macam mana cakap, they cannot fix to our needs actually. Okay, so that's why we got this OLAP lah actually. Okay, OLAP ni actually the definition is category of a software technology. It's actually a software technology that enables analysts and managers and executives to gain insight into data through fast, consistent, interactive access to a wide variety of possible views of information that has been transformed from raw data to reflect the real dimensionality of the enterprise as understood by the user. This one from the DBMS, Database Management System magazine, on April 1995. Okay, panjang definition dia. It's not that you have to remember this one. Yes, you get the idea here actually. Okay, on the enterprise view on this one. So actually I can say one of the critical goals that OLAPs actually ada some of these late in 1990s actually sebenarnya. On the 1990s, as you know, the computer still on the beginning punya part, is not powerful as we have nowadays. Okay, masa tu pakai Pentium 4 atau Pentium 3, 1990s memang tidak pakai hard disk, memang load slow gila. Okay, it's a slow and not flexible lah for query at that time. Okay, ini 90s 1991 until 1998 macam tu, 1997. Okay, so actually vendors like Microsoft, Oracle, what else, Hyperion, which one yang buat this I can say this vendor of this database ni is not have a good technology lah at that time to adjust the data, to mix the data. So one of the critical goals that all our vendors strive to achieve is to minimize the amount of processing time needed while the user navigating the data or querying the data. So how this OLAP is a solution for this one is by the achieve this pre-processing and storing every possible combination of dimension, measure and hierarchies before the user started their analysis. So this allows the data to appear instantaneously when user investigated the information or querying the information or the data. Okay, that's how OLAP is going to solve our problem here, to facilitate our information processing here. Okay, on the OLAP measures function. Okay, done on the first topic. We go to the second one on the OLAP major features and function. So there's this is the OLAP benefits. Of course, as I said, this increased productivity of end user, reduced backlog of application development for IT staff, retention of organizational control over the integrity of corporate data, and reduce query drag and network traffic on OLTP system or on the data warehouse, and improve potential revenue and profitability. Okay, this the goals of OLAP benefits that you will have or will get if you implement this all up carefully on your data warehouse. Okay, example of all application in various functional areas, of course, on the finance, sales and marketing, and manufacturing. Last time memang on this finance and accounting, because that's the easiest one. They want to look on the multi-dimensional side of this data. Okay, on the finance, of course, they look on the budgeting, activity-based costing, financial performance analysis, and financial modeling. On the sale, of course, the sale analysis, sale forecasting. Markets, marketing, on the markets research analysis, sale forecasting, promotion analysis, customer analysis, and market customer segmentation. And while for the manufacturing is production planning and defect analysis. Okay, OLTP versus OLAP. Okay, while the online transaction processing application generally do not require historical data, nearly every OLAP application is concerned with viewing trends and therefore require historical data. So OLTP application and database tend to be organized around specific process such as order entry. So all applications tend to be subject oriented, answering such questions as what product are selling well, or what are my weakest sales office at that time lah. Okay, you can see the difference here. For LTP, mostly look on the order entries by the numbers 1, 2, 3, 4, 5. It's a meaningless, while the OLA application subject to answer such of this question lah. What are the products selling well? We can see this segmentation. What the top 3 product that been mostly sell ke mostly purchased by the customers. Okay. All right, another one. This one is OLTP is on the relational. Okay, mostly what we doing on the chapter 4. Relational. Okay, primary key, foreign key, atomized, present, record at a time, process oriented. While the OLAP, they summarize everything. They use the historical data to see the trends, many records at a time, and subject oriented. Okay, macam juga the subject ni more on the broad general perspective lah. Okay. Oh, tadi tu topic 1, sorry. Baru kita masuk the second topic on this OLAP major features and function. Okay, tadi baru habis topic 1 sorry. Okay, okay, major features and function of application. Key features, although all applications are found in widely divergent functional area, all have the following key features, which is the multi-dimensional views of the data, and its support for complex calculations, complex query, and is a time intelligent, meaning that is faster to actually acquire the data and to get information from this OLAP software or technology. Okay, all application multi-dimensional view of the data, core requirement of building a realistic business model, provide basis for analytical processing through flexible access to corporate data, and to the underlying database design that provide multi-dimensional view of data should treat all dimensions equally. Okay, this is just some criteria on these multi-dimensional views of the data. While support for complex calculation must provide a range of powerful computational methods such as that required by sales forecasting, which use trend algorithms such as moving average and percentage growth. And mechanism for implementing computational methods should be clear and non-procedural. Like this one on this moving average, this one meaning you have, okay, this is sorry, okay, this is forex this on the gold metal, actually metal forex gold. Okay, this is okay, yang kuning tu is moving average 50, moving average 50. So all, as you can see, all the graph here, this is, we call it candle chart. Okay, all is on the above of this moving average 50. Let's say I move to the simple one, MA 200. Still on the H1 punya time frame. Still all this bar candle chart. Okay, actually you can change this one. You want to the graph boleh, okay, macam ni, or you can do this what is called line chart, bar chart, biasa candlestick ni. So as you can see, this is moving average 200. So right now gold is on the uptrend. Okay, so actually I can do lagi moving average on 50 to 100s, depends on how you want to do the technical analysis of your chart graph. So I know this is uptrend, so it's on the buy lah, or maybe you can sell, so depends. Before this gold on the downtrend, as you can see here, but now it's break this area sebenarnya, so it's on the uptrend, maybe for the moment lah actually, because there's some support level here, belum break lagi this one. Okay, right, this is something you can learn lah. Okay, I think they're gonna be goes to that area and this area. Okay, maybe after this area, if they broke, they go up. Maybe if they broke, they go down more. Okay, all right. Okay, that's how you forecasting lah. So tadi kita nak forecast on the yes, the price of the gold. Like now is 1868. Nanti lagi 2-3 hari maybe naik sampai 19 balik ke? Who knows? If you buy, you got the profit lah. If you sell, naik lagi, you MC or margin call, loss lah sebenarnya. Okay. Okay, tadi just selingan what is the moving average or percentage growth. Okay. Okay, another one. On the time intelligence, key features of almost any analytical application as performance is almost always judged over time. So we gonna compare what in the past and what in the actual time. How is the percentage growth? Okay, time hierarchy is not always used in same manner as other hierarchies. I pun tak nak explain this one. Concepts such as year to date and period over period comparison should be easily defined. Okay, meaning that in this all up you can compare easily from time to time from the historical data on what actually what's the performance of the company doing on at the time compared to the last time. Okay, and we want to predict at the future. Is it our product will sell well or not? Okay, what segments, what the customer we should tackle on. So this is on this time intelligence. Representing multi-dimensional data, example of two-dimensional query, what is the total revenue generated by property sale in each city in each quarter of 1997? Imagine that you have this some basic graph or basic bar chart. Can you do this query, get the information right on time? Of course not. So we need to have this multi-dimensional query, which is OLAP ni, so that we can analyze our historical data at the as soon as possible lah. We can get information as soon as possible. We can compare and try to improve in the future. Choice of representation is based on type of query and user may ask, okay, and compare representation 3-field relational table versus 2-dimensional matrix. So this one 3-field relational table. So we can compare city on the quarter, on the sales of the 1997. So not just 2-dimensional, mostly like the graph, basic graph, relational database. Alright, it's example tadi city quarter, that's what the city, Glasgow, London, Aberdeen. Okay, quarter 1, quarter 2, quarter 3, quarter 4. This one kan satu tahun ada 12 bulan bagi dengan 4. So 1 hingga 3 bulan, 1 bulan sampai bulan 1 dan bulan 3 4 kali 3 12 1 bulan 1 bulan 3 quarter 1, bulan 4 sampai bulan 6 is quarter 2, 7 sampai 9 quarter 3, and 10 sampai 12 quarter 4. Okay, so we can look on the performance of every city of this company ni ke. Alright. Alright, representing multidimensional data, example of three-dimensional query, what is the total revenue? Okay, sama je sama macam atas tadi. Compare representation for field relational table versus three-dimensional cube. So actually we can do more lah on this OLAP actually. On OLAP ni is this one on 4. House, property types on the city, what is sales, what the recent time and revenue. This is three-dimensional. Okay, imagine that you got four-dimensional lah sebenarnya macam mana, or maybe you got another one here. Alright, this is about OLAP lah actually. So representing multi-dimensional data, cube represent data as a cell in an array. A relational table only represent multi-dimensional data in 2 dimension. So multi-dimensional OLAP servers use multi-dimensional structure to store data and relational between the data. And multi-dimensional structure are best visualized as cube of data and cube within cube of the data. Each side of cube is a dimension. A cube can be expanded to include other dimension. Actually, we got another exercise later on this, how this cube representation ni. Okay, try to just hadamkan dulu this one lah. Okay, on the OLAP server tadi, a cube support metric arithmetic, multi-dimensional query response time depend on how many cells have to be added on the fly. On the fly too, and when we going to do the processing query. Number of dimension increase, number of the cube cell increase exponentially. Okay, meaning that we have more data, there's more cube on our database OLAP ni. However, majority of multi-dimensional queries use summarized and high-level data. Solution is to pre-aggregate, consolidate all the logical subtotal and total along all dimensions. Pre-aggregation is valuable as typical dimension hierarchical in nature. Example, the time dimension hierarchy, years, quarter, month, weeks, and days. Okay, this one a nature punya lah. Okay. And predefined hierarchy allow logical pre-aggregation and conversely allow for logical drill down. So it support the common analytical operation here on the consolidation, drill down, and slicing and dicing. Of course, on the consolidation, aggregation of data such as simple roll up or complex expression involving interrelated data, something that we can make a connection from one to another. This one drill down is reverse to consolidation, terbalik daripada this consolidation, and involves displaying the detailed data that comprise the consolidated data. Okay, and the slicing and dicing, also called the pivoting, refer to the ability to look at the data from different viewpoint. Okay, macam kompleks dekat sini kan. Okay, as you can see here, okay, this is all up here. We got the drill down and roll up. Okay, this is drill through the detail, like drill down tadi lah. Macam mana consolidation kat sini consolidation sepatutnya. And drill across another all-up service. Okay, dia macam imagine from the product category. Okay, what the sales we have at that time. We can do on the data warehouse ni everything lah, on the summarize of the data, detail of the data. So OLAP ni we want to extract the data from different dimensional ya. Okay, slicing and dicing ni. Yes, imagine you have a one cube ni. Okay, one cube have berapa surface? Ada 8 kan? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 sorry. So we got the X, Y, Z ni lah. tak apa, kejap nanti kita buat exercise tu, we know actually how to tackle on this one. Okay, on this OLAP server can store data in a compressed form by dynamical selecting physical storage organization and compression technique that maximize space utilization. We got dense data example that exists for high percentage of cell can be stored separately from sparse data example significant percentage of cell are empty. Another one, ability to omit empty or repetitive cell can greatly reduce the size of the cube and the amount of processing, allow analysis to exceptionally large amount of data. And in summary, pre-aggregation, dimensional hierarchy, and sparse data management can significantly reduce the size of the cube and the need to calculate values on the fly. So remove the need for multi-table joins and provide quick and direct access to arrays of data, thus significantly speeding up execution of multi-dimensional queries. So in 1993, this has been formulated 12 rules of the basic selecting OLAP tools. One, we look on the multi-dimensional conceptual views. Another one, transparency, accessibility, consistent reporting performance, client-server architecture, generic dimensionality, dynamic sparse metric handling, multi-user support, unrestricted cross-dimensional operation, initiative data manipulation, flexible reporting, and also the unlimited dimension and aggregation of the level. Okay, finish. There are proposals to redefine or extend the rule, for example, to also include comprehensive database management tool, ability to drill down to details such record level, incremental database refresh, and SQL interface to existing enterprise environment. Alright, habis on the OLAP server features and function. Okay, memang panjang sikit on that one. Okay, OLAP servers, OLAP major features and function. Okay, I think we stop for the first part on this chapter 7, chapter 6 chapter 7 lah. Kan chapter 6 ni.
Okay, this will be the continuation.
Right. I continue on the last chapter 7, okay, on the OLAP models. But before that, I want to go to this favorite question for this chapter, which is you have to draw 2-dimensional and also draw a 3-dimensional cube. Okay, so ready your pen and paper? We start right now. Okay, this is one of the questions. They will give you a table like this one. The table can be longer with a lot of records. Okay, this one is the simplest, I can say the simplest question on this one. Yang paling senang. Okay. Okay, the first question, draw a 2-dimensional matrix for UK region. Okay, mostly they will ask you specifics on 2-dimensional, meaning that they just want you to extract the data from, okay, in this case for the UK region. So you look on the region here. Okay, this is about the PS5 product version. They got the total sales, and this is the quarter 1, 2, 3, 4. Okay, so now they want you to draw a two-dimensional metric for UK region. Okay, I'm going to show you with this pen from here. Okay, yep. Okay, to tackle the first question is by, okay, you need to identify which one actually you want to do first. Okay, all right. As you see here, there's two product version, which is the PS5 digital edition and the PS5 standard. Okay, so meaning that we have two product version data that we have to cover. Okay, we got quarter 1, 2, 3, 4. Okay, so the best thing is by you type the quarter first, and then we got the types. Kan, it's a product version. Okay, hope you can understand this one. Okay, faham tak? Meaning that, okay, here is our Q1. Okay, I hope you can see my writing here, Q1. So this one is Q2. Of course, kita ada Q3. And the last one will be Q4. Okay, that's cover for the quarter. Okay, soalan ni orang ke sini pula, sorry, tak apa. Okay, I draw the line here. Okay, because we got two products version here, which is what it is. Kalau kita nak buat two-dimensional matrix ya, table lah sebenarnya lebih kurang ni. So product version that we have here only two. So the first one I think kita buat PS5 on the digital. You kena tulis penuh digital. Okay, edition. And then we got the PS5 standard. Okay, untuk I tulis pakai typing lah senang. Okay, tak apa, ni nak cepat ni sebenarnya. Alright, so you're gonna have a table like this. Okay, buat table tu cantik sikit, use the ruler. My case here using the pen ni, sorry. Okay, 1, 2, 3 and 4. Okay, because the question is about the draw two-dimensional metric for UK region, so you just look on the UK region. Sekejap. Tak apa. I think this one should be okay ni. Okay, so yang senang on this, the first soalan ni, draw a two-dimensional. So kita tengok quarter 1 for the UK region, how many? For the PS5 digital edition, this one is a 333. So you place tu 3, 3, 3. PS5 standard quarter 1 is 2, 2, 2, and continue on the quarter 2. Okay, sambunglah quarter 3, and also for the quarter 4. Jangan tersilap salin meaning that look carefully. This one is PS5 digital edition, quarter 4 252, and for the PS5 standard UK region is quarter 4 887. Okay, so, surprisingly memang paling senang lah for this two-dimensional matrix, this one. Okay, settle. That's how you tackle the first question on draw two-dimensional matrix for whatever lah, the things that they want to have in your two-dimensional matrix here. Okay, done. Make sure you look on the how many types of products or version things that they have. Okay, maybe you got 3, 4 maybe, and then this one mostly on about the length of the years lah. It can be others, alright. Sometimes maybe you can put this PS5 digital on down here, and quarter on the up pun is okay. But we want to have a simplest table matrix that you can produce on this one. So I think the best for this one is like this. Okay, settle the first question. Now we go, okay, you can screen capture this one. Done for the first one. Now we have to draw a three-dimensional cube. Okay, this one a bit tough, not a bit tough, it's still okay je actually sebenarnya. Alright, the first one we have to do, because this is a cube, so you kena buat cube like a cube tu lah. Okay, macam ni, then macam ni cube. Okay, this is my first cube. Alright. Okay, because the cube, okay, right now they don't mention anything, so meaning that you have to pick either you want to choose the UK region or maybe you choose the Asian region. So I think here better kita ambil je this Asian region pula lah, because tadi we have cover for the UK region. Okay. Alright, as you know we got two product version here, so sebenarnya dia buat macam ni, kita buat macam ni, because we want to cover it's better this one. Why not we do this as a, okay, type lah this one This one is a PS5 digital. Alright. And then the second one is about the PS5 standard. Okay, you're gonna have like that. Okay, so another thing is kita ada two region, which is first is on the UK region. Okay, kat atas ni sebenarnya kita buat UK region, change the colour. Kalau boleh you buat same colour. This one I just want you to have a different you can identify lah UK region. This one is Asian region. Ada yang nak beli PS5 ke? So, boleh roger ni, boleh datang rumah. Okay, kita dah cover this one. So sekarang ni, because this is three-dimensional cube, so meaning that we can retrieve three data lah actually from this cube. Okay, so kat sini apa sebenarnya? Kat sini you kena buat, this one is a Q1, this one is a Q2, and then kita kena sambung balik. Sorry, my cube ni teruk gila. So this one is gonna be the Q3, and this one is the last cube for Q4. Okay, yang ni kita abaikan. Alright. Saya bagi cantik sikit you punya cube tu. Your cube should be nice nice as you can see on the textbook. Alright. So, ignore the up this one. So meaning that this one will a cube, this one like a cube, memang like kotak tu kan. So the first one, so PS5 digital edition. So now we look, because we have put this one is Asian region, okay, meaning that this is one cube lah sebenarnya ni. Kalau you perasan like this one, okay, kotak pertama yang this one, nampak pula kali dia. Okay, this one lah. This first cube ni, okay, ni first cube. Imagine dia in one box lah sebenarnya kan. Okay, this one yang atas ni is about Asian region. This one is PS5 digital edition, and then another one there is PS5 standard. So meaning that kita kena letak, okay, this one mewakili quarter 1, quarter 2, quarter 3, quarter 4. This one, the first row is for the quarter 1. So you look on the quarter 1 PS5 digital edition, how many? For the Asian region, quarter 1, the first one is 585. For the PS5 standard, this one ni 585. This one the number that I get. This one is for standard 5, because if it's a standard Asian region 545. So you continue for the rest of the quarter. So next one, quarter 2 digital edition is 747, and then the next one 454. Quarter 3 is 656, 562, 221, 325, and 545. All right. Okay, this the three-dimensional cube that you should draw for your answer on the second question. All right, how we marking your this thing is, first we look on the dimension level. Okay, first on the dimension level. Okay, mostly kalau macam ni markah dia is 8 kalau tak silap. Dimension level, because kita ada 3 level, which is on the region, this one, on the version, and of course the quarter ni. So baru you dapat 3 markah. Another one, we look on the value insertion. Maksudnya value that you copy tu lah. So we got 4 value here. So ni kira 1, 2, 3, 4. So markah kat sini is 4. And kita ada last one is about the format cube. Maksudnya lukis cube ni cantik-cantik lah, like memang kena like this. We got another 1 mark. So total here 4 tambah 5 tambah 3 is 8 marks for this one. Okay, yang atas tadi for the 2-dimensional, mostly dalam 7 markah macam tu. Biasa yang 3-dimensional ni lagi banyak markah lah compared to the first 2-dimensional. Alright, meaning that because first one we have done for the UK region, no need to do that. So kita cover for the Asian region. So we got a mixed data lah this one. So you just copy je from the table that they give it to you. Okay, senang je sebenarnya. It's not too hard. just you want to display your data here nicely, should be okay lah. Alright, hopes we cover for this two-dimensional and three-dimensional cube. Alright, you can rewind my video. So for now, I will continue on the OLAPS model. Sikit lagi. Okay, categories of OLAPS tool. Oh, okay, actually before that, we have, remember that I give you this on the textbook. I said this is a textbook for data warehouse, this one by Paul Raj Ponya. As you can see at the end of this slide, yes, they get this the content for this slide actually from that textbook, so you can always read and refer to that textbook for better explanation. Okay, the textbook is here. Okay, you can just Control F, search, find, type your OLAPS. You're gonna go, yes, this one OLAP model. And before that is about that the one that we have covered for the first part of our OLAPS chapter, slice and dice, how actually the things is they give you a better example compared to my explanation last time. So it takes some time to read on this one, but most important thing is you should know how to draw the two-dimensional and three-dimensional for this particular chapter. All right. Okay, for this OLAP model, we got, I don't know why this is a blank. Okay, just ignore that. Categories of OLAP tool, we got 3, but actually there's one more, which is DOLAP, they call it desktop OLAP. Okay, but we go this one. OLAP tool are categorized according to the architecture of the underlying database, meaning that how they built actually. So 3 main category of OLAP is a multi-dimensional OLAP. They call MOLAP, MOLAP, or MDOLAP. So mostly I think they just do this MOLP for the abbreviation. So the first one is multi-dimensional. The second one is relational OLAP, ROLAP, also called the multi-relational OLAP. And then we got MQE, the managed query environment. So we go one by one. The first one on the multi-dimensional OLAP use specialized data structures and multi-dimensional database management system to organize, navigate, and analyze the data. Okay, this is the thing that's this multi-dimensional OLAP do. So data is typically aggregated and stored according to predicted usage to enhance query performance. Okay. As you know, in my OLAP ni they do fast query and fast retrieve of information and data. Okay, on this multi-dimensional OLAP use array technology and efficient storage technique that minimize the disk space requirement through sparse data management. So it provides excellent performance when data is used as designed, and the focus is on the data for specific decision support application. Okay, more on the definition on this one. Traditionally require a tight coupling with the application layer and presentation layer. This one on the transaction of the files, on the transfer of the file. Recent trends segregate the OLAP from the data structure through the use of published application programming interface API. So this is how the architecture work. We got the database application logic layer here. They're gonna transfer to the OLAP server. That's how the end user access from the presentation tool what they see from the API tadi on the application programming interface. So they just request get the result as soon as possible from here. Okay, development issue on these OLAPs. What is the problem? Is underlying the data structure are limited in their ability to support multiple subject areas and to provide access to detailed data. Navigation and analysis of data is limited because the data is designed according to previously determined requirement. Okay. And then OLAP product require a different set of skills and tools to build
and maintain the database, thus increasing the cost and complexity of support. Okay, that's a issue that they mentioned on this MOLAP tool. We're going to move on to the next one on the relational OLAP or ROLAP. It's the fastest growing style of OLAP technology, support RDMMS, relational database management system product using a metadata layer, avoids need to create a static multi-dimensional data structure, facilitate the creation of multiple multi-dimensional views of the two-dimensional relation. This one macam yang kita buat tadi on the two-dimensional, three-dimensional. Okay, to improve performance, some product use SQL engine, search query language engine, to support complexity of multi-dimensional analysis, while others recommend or require the use of highly denormalized database designs such as the star schema. You remember the star schema? Yes, we relate from table to table with the foreign key, primary key. Okay, this is the architecture of the ROLP tools. So they're gonna have this application logic layer on the rollup server. So the user will request the data from this ROLP server, and they get the result from the database layer here. SQL, you're gonna take some time, but nowadays computer is fast enough, so it should be no problem. Okay, done for the rollups. We got another one, we call it hybrid OLAP or HOLAP. Provide limited analysis capability either directly against RDMS product or by using an intermediate MOLAP server. It delivers selected data directly from the DBMS or via a MOLAP server to the desktop local server in the form of the data cube, where it is stored, analyzed, and maintained locally. Simple to install, reduce cost and maintenance. Issue of this hybrid OLAP is significant data redundancy and may cause problem for network that support many users. So you know, data redundancy is the thing that we don't want in our database. Okay, ability for each user to build a custom data cube may cause lack of data consistency among the user, as long for contribute for this data redundancy, and only a limited amount of data can be efficiently maintained. Alright, we have another one, we call it desktop OLAP or DOLAP. Store the OLAP data in the client-based files and support multi-dimensional processing using a client multi-dimensional engine. Require that relatively small extract of data are held on the client machine or is distributed in advance or on demand through the web, and data may hold on the disk or in the RAM. Some allow only read access, meaning that this data is stored temporarily. Okay. Administration of the OLAP database is typically performed by a central server of processing routine that prepare data cube or set of data for each user. Once processing is done, each user can access their portion of the data. Okay, gonna take some time, I see from there. Okay, the development issues of the DOLAP is provision of appropriate security control to support all part of the DOLAP environment. Because the data is physically extracted from the system, security is generally implemented by limiting the information compiled into each cube. So reduction in the effort involved in deploying and maintaining the DOLAP tools, and the current trends are toward thin client machine. Alright, I think just take note lah what the important things on this issue, mostly on the security control, support parts. Just take few lah, make sure that you cover all these models on the OLAP ni tadi. Okay, kita ada ROLAP, HOLAP, DOLAP and MOLAP, the first one. Okay, summary. Akhirnya finished, finally is finished on this OLAP. OLAP is critical because its multi-dimensional analysis, fast access and powerful calculation exceed that of the analysis method. Is defined of the basis court's initial 12 guidelines. Remember the first part I share with you. OLAP characteristics include multidimensional view of the data, interactive, complex analysis facility, ability to perform intricate calculation, and fast response time. And dimensional analysis is not confined to 3 dimensions that can be represented by a physical cube. Hypercube provide a method for representing a view with more dimension. And ROLAP, MOLAP are two more major LOPS model. The difference between them lies in the way the basic data is stored. A certain the merge switch model is more suitable for environment. OLAP tool have matured. Some RDFs include support for OLAP. Okay, actually they're not like limited to the 3-dimensional. Okay, this is the reference. It can be sampai 6-dimensional. I think I nampak 6 kot. The first part of this okay, this one hypercube ni. Okay, hypercube ni meaning that macam-macam you can get from one cube ni. Okay, take your time to, I strongly suggest you this is 4-dimensional, 6-dimensional, I think up to 6 lah. Take your time to read on the textbook ni. If you still have a question on this thing or anything, you can post on the chat group. Alright, that's all for today's chapter, for chapter 7. Okay, take your time to read on the text.
Okay, so that this will be actually discussions about OLAP, no? And again, I just want to reiterate that in OLAP, we had what we called relational OLAP, no? Multidimensional OLAP, hybrid OLAP, and specialized SQL servers, or yung desktop OLAP as what our video mentioned earlier. So, roll up performs aggregation of the data cube in any of the following ways. So by climbing up concept hierarchy of the dimension and by dimension reduction. So a while ago, based on our video, it is presented a mobile modern phone security, which roll up is performed by the concept of hierarchy of the dimension location. The drill down is the reverse operation of the roll up. Okay. And the slice operation reflects one particular dimension from a given cube and provides a new subcube, considering some mobile modem phone security. And the dice select 2 or more dimensions from a given cube and provides a new subcube. And for a pivot, the pivot operation is also known as rotation. And it rotates the data access in view in order to provide an alternative presentation of data. Okay, and I think that's it. Now again, so OLAP versus OLTP. So our video also mentioned that the data warehouse involves historical processing of information. The operational database involves day-to-day processing. So OLAP systems are used by knowledge workers such as executive managers and analysis. On the other hand, operational database or OLTP system are used by clerks, DBAs, or database professional. So OLAP useful in analyzing the business, OLTP used in running the business. OLAP based on star schema, snowflake schema, and fact constellation schema. On the other hand, OLTP based on entity relationship model or yung ARM natin or ERD. So, and a lot more. Of course, when we say OLAP, it is highly flexible. For OLTP, that is provides high performance actually. For the data size, or database size, OLAP is from 100 GB to 1 TB. Unlike OLTP, that database size is from 100 MB only to 1 GB. So that's why it is important for us to use OLAP rather than OLTP. Okay, so I think that's it for this topic.